Precious and welcome to the section of Grade 9 CBSE Maths class. Today we are looking at the chapter number 6, Lines and Angles. Basically in this chapter we are going to discuss about the angles made by lines. When two lines intersect each other or when two lines meet, there forms angles. What is the peculiarity of that angles? And how we classify different types of angles, or what is the criteria regarding the classification of angles. Then based on this classification we arrive at some theorems, and using that theorem we have to solve some solutions or we have to solve some problems. Then in the last section we will go through angles and property of a triangle. That also relates the angles. When a triangle is formed using three lines, there forms three angles. Then what is the sum of the angles in a triangle, or what is the peculiarity of angle that formed in different types of triangles. Then there also a theorem is stated and we have to solve the problems related to angles and property of a triangle. That's all about a vague idea of this chapter. First of all, before going through the peculiarities of angles or the classification or the criteria for classification of angles, we have to mention some basic terms related to lines and angles. We have to define some basic terms related to lines and angles. The first one is a line segment. First one is a line segment. You all heard about the name line segment. What is a line segment? You know that a line is an infinite length, is an infinite breadthless length that we studied in the Euclid's assumptions or Euclid's definitions. We have studied a line is a breadthless length which is of infinite length or infinitely long. If a line having two endpoints, then it is called a line segment. If a line having two endpoints, then it is called a line segment. Then we can easily define line segment as a line with two endpoints. A line with two endpoints is a line segment. A line with two endpoints is a line segment. Clear? When I am considering a line, it extends up to infinity. So we have to put the dotted lines in the left and right positions. It indicates that it is extending towards the infinity on the right and left sides. When I am considering two endpoints, put it as A and B. Then A is the left endpoint and B is the right endpoint of this line. Then we can say that AB is a line segment. Then we can say that AB is a line segment. Okay, clear? Now, the second term we have to define is a ray. What is a ray? A ray means if a line having only one endpoint and the other point extends up to infinity. If a line having only one endpoint, which is A, and if the other end extends up to infinity, that means it is of infinite length on the other end. One end is A, then it can be called as a ray. That means a line having only one endpoint and other ends extends up to infinity is called a ray. The next term we have to define is, what do you mean by collinear points? What do you mean by collinear points? When I am considering a line segment X, Y, this is our line segment X, Y, and I am considering 3 points A, B and C. What is the peculiarity of these 3 points, or what is the importance of these points? These 3 points A, B and C lies on the same line segment XY. These 3 points A, B and C lies on the same line segment xy, then we can say that this A, B and C are collinear points. Then we can say that this A, B and C are collinear points. Then how will we define collinear points? The points which are on the same line segment are called collinear points. If B is not on the line, it is outside the line, then we can say that A, B and C are not collinear. Then it is known as non-collinear points. If the points under consideration are on the same line segment, then that points are collinear points. Otherwise, it is called non-collinear points. Otherwise, it is called non-collinear points. Now, it is clear what is collinear and non-collinear points. The points which lies on the same line segment are called collinear points. The points which are not on the same line segment are called non-collinear points. Now, we explained line segment, array, collinear points, non-collinear points. Next, we are going to classify angles based on the value of the angle. We are going to classify angles based on the value of the angle. Before classification, we need to know how an angle is formed. How an angle is formed. If two line segment starting from the same point, if two line segment starting from the same point, consider the common point as A, and the first line segment is AB and the second one is AC. First line segment is AB and the second one is AC. Here A is the vertex. Here A is the vertex and AB and AC are the arms of the angle. AB and AC are the arms of the angle. Then we got an angle BAC or CAB. This is our angle. Clear? When two line segments intersect each other, at the point of intersection, we are having four angles like this. That means if two line segments starting from the same point, or if two line segments intersect each other, or if two line segments meet at a common point, then in all these cases there forms angles. In all these cases there forms angles. That's how an angle is formed. Now, on the basis of the values, we can classify angles. That means if the value of angle is 0 to 90 degree, if the value of angle is 0 to 90 degree, 90 degree is not taken, that is less than 90 degree. 0 to 90 degree means less than 90 degree. Less than 90 degree. Up to 89.9. Not 90 degrees taken. 0 to 90 means less than 90 degree. If the value of angle is less than 90 degree, then it is known as acute angles. If the value of angle is less than 90 degree, that means 0 to 90, then it is known as acute angle. Then it is known as acute angle. If the value of angle is accurately equal to 90 degree, if the value of angle is equal to 90 degree, the value of angle is accurately equal to 90 degree, the value of angle is accurately equal to 90 degree, then it is known as a right angle. Then it is known as a right angle. That means if the value of angle is less than 90 degree, then it is acute angle. If the value of angle is accurately equal to 90 degree, then it is a right angle. First one is acute angle. First one is acute angle, that is 0 degree to 90 degree. Means 90 degree is not included, excluding 90 degree. That means less than 90. That means less than 90. Then it is known as acute angle. Then it is known as acute angle. If the value of the angle is accurately equal to 90 degree, if the value of the angle is accurately equal to 90 degree, that means 90 degree angles are called right angles. 90 degree angles are called right angles. Then if the value of angle is greater than 90 degree and less than 180 degree, that means 90 degree to 180 degree. 90 and 180 are excluded, not including 90 and 180. This can be stated as greater than 90, greater than 90 and less than 180 degree. Then the angles are known as obtuse angle. Then the angle is obtuse angle. Now, if the value of angle is less than 90 degree, then it is known as acute angle. If the value of angle is equal to 90 degree, then that angle is known as right angle. If value of angle is greater than 90 degree and less than 180 degree, that greater than 90 degree and less than 180 degree, then it is known as obtuse angle. Then it is known as obtuse angle. Then if the value of angle is equal to 180 degree, if the value of angle is equal to 180 degree, if the value of angle is equal to 180 degree, then that angle is named as straight angle. Then that angle is named as straight angle. Then that angle is named as straight angle. Then if the value of angle is greater than 180 degree and less than 360 degree, that is 180 to 360 degree, which can be stated as greater than 180, greater than 180 and less than 360, greater than 180 and less than 360. That means 180 to 360, up to 360. It is known as a reflex angle. It is known as a reflex angle. It is known as a reflex angle. Now we have gone through acute angle, right angle, obtuse angle, straight angle and reflex angle. What is acute angle? The angle whose measure less than 90 degree are called acute angles. If the value of angle is equal to 90 degree, then it is a right angle. If the value of the angle is greater than 90 and less than 180 degree, then it is obtuse angle. If the value of the angle is equal to 180 degree, then it is a straight angle. Then if the value of angle is greater than 180 degree and less than 360 degree, then it is known as a reflex angle. Then it is known as a reflex angle. That's how we classify angles as acute, right, obtuse, straight and reflex. Now when we consider an angle like this, you know that this is less than 90 degree angle. This is less than 90 degree angle. This angle is less than 90. Therefore, this is the acute angle. This is the acute angle. When we are considering an angle like this, you know that this is equal to 90 degree. This is equal to 90 degree. A right angle is denoted like this. In the corner, like a square, we are representing the right angle. Not like this. A right angle is denoted like this. This is equal to a right angle. Then when we are considering an angle like this, you know that this is greater than 90 degree and less than 180 degree. Then this is known as obtuse angle. Then this is known as obtuse angle. And when we are considering like this angle is equal to 180 degree. That means this is a straight angle. This is a straight angle. And when we are considering like this angle, not take this angle, this one is greater than 180 and less than 360. Therefore, this can be called as a reflex angle. This can be called as a reflex angle. That is acute angle, a right angle, obtuse angle, straight angle, and a reflex angle. This is the classification of angles based on the values. This is the classification of angles based on the values. Now, we have to consider what is complementary angle and what are supplementary angles. What are called complementary angles and what are called supplementary angles. When we are considering two angles, suppose it be x and y. When we add x and y together, and if we are getting 90 degree as the answer, when considering two angles, let it be x and y. When adding these two x and y, if we get 90 degree, that means a right angle, then these x and y are called complementary angles. Then these x and y are called complementary angles. That means the angles whose sum is 90 degree are called complementary angles. The angles whose sum is 90 degree are called complementary angles. Then if we are considering another two angles A and B, and when we add A and B together, if we get 180 degree, when we considering two angles, let it be A and B, when we add this A and B together, and if we get 180 degree as the answer, then A and B are supplementary angles. Then A and B are supplementary angles. That means the angles whose sum is 180 degree are called supplementary angles. The angles whose sum is 90 degree are called complementary angles. The angles whose sum is 90 degree are called complementary angles, and the angles whose sum is 180 degree are called supplementary angles. Clear? Now we completed complementary and supplementary angles. Angles whose sum is 180 degree are called complementary angles, and the angles whose sum is 180 degree are called supplementary angles. Now, when we are considering a pair of angles, that means when we are considering a pair of angles, two angles in a line segment, or when two line segments intersect each other, here we got two angles, let it be x and let it be y. You know that this is a straight line. The angle formed in the straight line togetherly is 180 degree. The angle formed in the straight line togetherly is 180 degree. That is a straight angle. That simply means that this x and this y togetherly gives a straight angle. X plus y togetherly gives a straight angle. A straight angle means 180 degree. That is x plus y is equal to 180 degree. Like the same way, if any two angles in a line segment, or if any pair of angles in a line gives 180 degree as the sum, then the pair of angles are called linear pair. Clear? When two line segments intersect or meet or starting from the same point, then if the pair of angles formed here gives the sum of 180 degree, that means gives a straight angle, then this pair can be called as a linear pair. Here x plus y is equal to 180 degree. Therefore, we can say that x and y are linear pair. So, x plus y is equal to 180 degree. Therefore, x can be written as 180 minus y. or y can be written as 180 minus x. This is what called linear pair. This is what called linear pair. Now, we have go through the basic terms or basic definitions or basic ideas or basic classification related to lines and angles. Just remember what we have learned. First is line segment, then ray, collinear points, non-collinear points, acute angle, right angle, obtuse angle, straight angle and reflex angle. Then complementary and supplementary angles, and then linear pair. This is the basic idea we have to study the chapter lines and angles. If we have basic knowledge of these all terms, then we can easily go through this chapter and easily solve the problems using the theorems. In the theorems, these terms are very important. In the theorems, these terms are very important. So, this is the basic idea regarding the chapter lines and angles. I think all the basic terms are clear to you. We discussed about the basic terms regarding lines and angles and the classification of angles based on their values, and if pairs of angles are given based on their sum, how will we call complementary or supplementary or linear pair, like that. Then after these basic terms, after you studying the basic term, if you understand it well, then this chapter is not difficult for you. It is so easy. Then based on the definitions, we have some theorems. I'm going to explain first theorem here and with an axiom. First axiom which is given in your textbook is that when we are considering a line segment, or if adjacent angles of a line segment, if the sum is 180 degree, if the angles is 180 degree, then the non-common arms forms a straight line. That means if we are considering an angle like this, A, B and C, and here the adjacent angles are represented as X and Y. This is the adjacent angles. If the sum of these adjacent angles is 180 degree, that means if X plus Y is equal to 180 degree, then the non-common arms, put here a point as O, then the non-common arms, common arm is OC. Both the angles, we are having a common arm OC, and non-common arms are AO and BO. Here, if X plus Y is equal to 180 degree, that means sum of the adjacent angles is 180 degree, then we can say that the non-common arms forms a straight line. That means here we can say that AOB is a straight line. AOB is a straight line. This is axiom given in your textbook, that if two adjacent angles, if the sum of the adjacent angles is 180 degree, then the non-common arms forms a straight line. Here AOC is angle AOC is taken as X and angle BOC is taken as Y. These X and Y are two adjacent angles. If the sum of these adjacent angles, that is, if the sum of X and Y, X plus Y is equal to if 180 degree, then we can say that AOB is a straight line. Then we can say that AOB is a straight line. This is the axiom given in your textbook. And moving to the first theorem, theorem number 1. If you are watching this section with a notebook in your hand, just write this theorem as theorem number 1. Just take a notebook and write the notes as theorem number 1 based on the chapter lines and angles. In this chapter, we are going to discuss the first theorem, theorem number 1. Theorem number 1 states that when two line segments intersect each other, if two line segments intersect each other, then vertically opposite angles are always equal. If two line segments intersect each other, consider two line segments AB and CD. Here forms four angles. I am representing this as small letter A, B, C and D. Here in these four angles, vertically opposite angles are equal. That means A and D are vertically opposite angles. Therefore, we can say that A equal to D. B and C are vertically opposite angles. Therefore, we can say that B is equal to C. When two line segments intersect each other, the vertically opposite angles so formed are equal. This is theorem number 1. Very, very important theorem. Based on this theorem, we have to solve some problems. Just note it down as theorem number 1 and write it down. If two line segments intersect each other, then the vertically opposite angles so formed are equal. Here in this line segment AB and CD intersecting at a point, let it be O or any other point. Then we got four angles. I write this as small letter A, B, C and D. Here A and D are vertically opposite angles. Therefore, we can say that A is equal to D. B and C are vertically opposite angles. Therefore, we can say that B is equal to C. Clear? This is theorem number 1. And based on this theorem, we have to solve some problems. I already wrote 2 problems in the board and we can go through the problem. How we can solve this problem? Remember the theorem 1? Based on this theorem, look at the question. In figure, lines AB and CD intersect at O. This is AB, and this is CD. These two line segments intersect at O. This is the meeting point O. If angle AOC plus angle BOE is equal to 70 degree, angle AOC, which is angle AOC? Angle AOC, this is angle AOC. Let it be small letter X, which is angle BOE. This is angle BOE. Let it be small letter Y. And here in this problem given that angle AOC plus angle BOE is equal to 70 degree. That simply we can write X plus Y is equal to 70 degree. X plus Y equal to 70 degree. Then the question is that before that we are having one more condition. Angle BOD is equal to 40 degree. Angle BOD is equal to 40 degree. Okay. And we have to find angle BOE and reflex angle COE. Okay. We have to find angle BOE and reflex angle COE. That means we have to find angle Y. What is the value of Y? And then we need to find the reflex angle of COE. For finding reflex angle, we have to find the accurate value of COE. That's our question. So, given condition is that X plus Y is equal to 70 degree. That is angle AOC plus BOE is equal to 70 degree. Clear? Then angle BOD is equal to 40 degree. This is the condition. Okay. So, how will you solve this? We know that angle AOC, angle COE and angle BOE, these three angles are on a straight line AB. We already know that AB and CD are line segments. So, angle AOC, angle COE and angle BOE, these three angles are on a straight line AB. Therefore, these three angles constitute or togetherly forms a straight angle 180 degree. That is angle AOC X, angle BOE Y, and angle COE. The sum of these three angles is equal to 180 degree. That means X plus Y plus angle COE is equal to 180 degree. Here we know that X plus Y is equal to 70 degree. Therefore, angle COE is equal to 180 degree minus 70 degree, that is equal to 110 degree. Now we got COE as 110 degree. Now we got COE as 110 degree. First one is solved. We got COE, but we need the reflex angle of COE. So before moving to that, we need one more answer, which is angle BOE. BOE, that is Y. Now we need to find Y. So we know that vertically opposite angles are equal. We know that vertically opposite angles are equal. By theorem 1, we stated that if two line segments intersect each other, then vertically opposite angles so formed are equal. Here, angle X and this angle BOD are vertically opposite angles. We can say that angle AOC and angle BOD are vertically opposite angles. I just write as VOA, means vertically opposite angles. And these vertically opposite angles are equal. Therefore, we can say that X is equal to 40 degree. Therefore, we can say that X equal to 40 degree. Now, I am marking this X as 40 degree. Clear? By theorem 1, we know that vertically opposite angles are equal. AOC and BOD are vertically opposite angles. AOC and BOD are vertically opposite angles. Already given in the question that angle BOD is equal to 40 degree. Therefore, we can simply say that angle AOC is also equal to 40 degree. Now we got the value of x equal to 40 degree, and then we are having a condition x plus y is equal to 70 degree. We are having a condition x plus y is equal to 70 degree. Already given in this question that angle AOC plus angle BOE is equal to 70 degree. That is x plus y is equal to 70 degree. Here now we have the value of x as 40 degree, that is 40 plus y is equal to 70 degree. Therefore, we can say that y is equal to 70 minus 40. 70 minus 40 is 30 degree. Now we got the value of y as 30 degree. Now we got the value of y as 30 degree. This is the answer for angle BOE. Angle BOE is equal to 30 degree. Now it is solved. This is solved. Then we need the reflex angle of angle COE. We need the reflex angle of angle COE. How we find the reflex of angle COE? What do you mean by reflex angle? A reflex angle is the angle whose measure is greater than 180 degree and less than 360 degree. Here COE is equal to 110 degree. Angle COE is equal to 110 degree. To find the reflex of an angle, just subtract that angle from 360 degree. To find the reflex of an angle, just subtract that angle from 360 degree. Therefore, we can say that a reflex angle COE is equal to 360 minus 110. 360 minus 110 is 250 degree. That is reflex angle COE is 250 degree. Reflex angle COE is 250 degree. Now we got both the answers and find the angle BOE. We find the angle BOE as 30 degree. Then reflex angle COE. Angle COE is 110 degree. Therefore, reflex angle COE is 250 degree. Okay, clear? This is okay. Then we are having one more question. We are having one more question. The question is that in figure, lines XY and MN intersect at O. XY and MN are line segments. XY and MN are line segments. The intersecting point is O. This is the intersecting point. This is O. Angle POY is equal to 90 degree. Angle POY, this angle POY, this is 90 degree. Then angle A is to B is equal to 2 is to 3. Angle POM is A and angle XOM is B. The ratio of this angle is given as 2 is to 3. Then we have to find angle C. Then we have to find angle C. How to find angle C? We can find it one by one. First, I am going to find A, B. Then we can find C. The given conditions in the question. Given conditions in the question. Given conditions. That is, angle POY is equal to 90 degree. This is a given condition. Then angle POM is equal to A. Angle XOM is equal to B. This is also a given condition. Now a ratio is given that A is to B is equal to 2 is to 3. A is to B is equal to 2 is to 3. These all are the given conditions. Okay. How will you find A, B and C? We know that this angle POY and angle XOP are linear pairs. Look in the figure. Look at the figure. Angle POY, this is 90 degree. Then angle POX or XOP should also be 90 degree because these are linear pair. Sum of the angle should be 180 degree. Therefore, this whole angle is 90 degree. The whole angle should be 90 degree. Then we can say that angle A plus angle B is equal to 90 degree. Angle A plus angle B is equal to 90 degree. Now we got the sum of A and B as 90. We got the sum of A and B as 90. And the ratio of A and B as 2 is to 3. Using this condition, we can find A and B. To find A is equal to, here the ratio of A is 2 by the whole sum of the ratios 2 plus 3 5 into total value 90 degree. That is equal to 2 by 5 into 90. That is 90 by 5. What is the value 90 by 5? 1 into 5, 5. Remainder 4. 8 into 5, 40. It's 18. Then 2 into 18 is equal to 36 degree. We got the value of A as 36 degree. We got the value of A as 36 degree. Then what is the value of B? Therefore, B is equal to 90 minus 36. 90 minus 36, which is 54. Which is 54. That is B is equal to 54. Now we get both the values for A and B. Now we get both the values for A and B as A is equal to 36 degree, B is equal to 54 degree. What is the question? Question is that we have to find the value of C, not A and B. We have to find the value of C. For finding C, we need A and B. That's why we take the value of A and B first. Now look at the figure. The angle C is vertically opposite to angle MOY. The angle C is vertically opposite to angle MOY. Then angle MOY is equal to this is 36 and this is 90. That is 90 plus 36 is equal to 126 degree. Angle MOY is equal to 126 degree, which is vertically opposite to angle C. Therefore, we can say that angle C is equal to 126 degree. This is one method. Or otherwise, we know that angle B is equal to 54 degree. Vertically opposite to that angle, there is angle NOY. Angle NOY, which is vertically opposite to angle B. Therefore, it is also equal to 54 degree. Angle NOY is equal to 54 degree. Then we know that angle C and this angle NOY, that is 54 degree, forms a linear pair. Therefore, to find angle C, we have to subtract 54 from 180 degree, which also gives the answer as 126 degree. Both ways we can solve this question. First way is angle C is vertically opposite to angle MOY. We have the value of MOY, that is 90 plus 86, 126 degree. Then next method is angle NOY is vertically opposite to B. B is 54 degree. Therefore, angle NOY is also 54 degree. Then to find C, subtract this 54 degree from 180 degree. That is 180 minus 54 is equal to 126 degree. Now the question is solved. Find C. What is the value of C? Value of C is 126 degree. These are the problems related to theorem number 1. Theorem number 1 is if two line segments intersect each other, then the vertically opposite angles are equal. These two problems are related to the same theorem. And for the problem, for this to be solved, theorem number 1 is used. I think it's completely okay for you. Moving to the next section, our next section under consideration is parallel lines and transversal. Parallel lines and transversal. If a transversal intersects a parallel lines, then there are some specific features for angles formed in that case. We have to identify what these specific features are, or we have to identify how these angles are special, or what is the special features of these angles. Before explaining the features of that angles formed from a transversal intersecting a parallel line, we have to show a figure of parallel lines which is intersected by a transversal. So, these are two parallel lines. Parallel lines simply means two lines having distance in between them is same everywhere. That means these two lines never intersect each other. They maintain the same distance everywhere. They are called parallel lines. Let it be AB and XY. AB and XY are two parallel lines. Now, a transversal is going to intersect these two parallel lines. A transversal means if this parallel lines is taken horizontally, then a vertical line intersecting these two parallel lines. That's a transversal. This is a transversal. Let it be MN. Now, AB and XY are parallel lines. MN is the transversal. we can say AB and XY are parallel lines. In mathematical form, we can write AB parallel to XY. AB parallel to XY. And MN is the transversal. MN is the transversal. Okay. Now, how many angles are formed here? 1, 2, 3, 4, 5, 6, 7, 8. Here, 8 angles are formed. I am marking this angle as 1, 2, 3, and 4. Then 5, 6, 7, 8. These are the 8 angles formed when a transversal intersects two parallel lines. AB and XY are parallel lines. AB parallel to XY, and the transversal MN intersects these two parallel lines. Then we got 8 angles. 1, 2, 3, 4, 5, 6, 7, and 8. These 8 angles have some specific features. Before explaining the features of these angles, we have to mention the type of the angles or criteria of the angles or classification of the angles here. Here, there is some importance for angle 1 and 5 and angle 2 and 6. Then angle 4 and 8. Then angle 3 and 7. These pairs have a specific name. Angle 1 and 5, angle 2 and 6, angle 4 and 8, angle 3 and 7. These have a specific name, and these pairs can be called as corresponding angles. These can be called as corresponding angles. So we can say that angle 1 and 5 are corresponding angles. Angle 2 and 6 are corresponding angles. Angle 4 and 8 are corresponding angles. Angle 3 and 7 are corresponding angles. Now, like the same way, we have some specific features for angle 3 and angle 5. Angle 2 and angle 8. What is the feature of this? Angle 3 and 5 and angle 2 and 8. These are called as alternate interior angles. These are called as alternate interior angles. Clear? Angle 3 and 5. Angle 3 and 5. These are alternate interior angles. Angle 2 and 8. Angle 2 and 8. These are also alternate interior angles. Now moving to another classification. Angle 4 and 6. Angle 4 and 6. Angle 1 and 7. Angle 4 and 6. Angle 1 and 7. These also have a specific name. These are known as alternate exterior angles. Alternate exterior angles. Alternate exterior angles. Clear? Now, look at the figure and find the corresponding angles, alternate interior angles, alternate exterior angles. AB and XY are two parallel lines. MN is the transversal intersecting AB and XY. When a transversal intersects a parallel line, there forms 8 angles. Then I mark these 8 angles as 1, 2, 3, 4, 5, 6, 7, 8. Then 1 and 5, 2 and 6, 4 and 8, and 3 and 7. These are the corresponding angles formed here. Then 3 and 5 and 2 and 8 are called alternate interior angles. Are called alternate interior angles. Are called alternate interior angles. Then 4 and 6 and 1 and 7. 4 and 6 and 1 and 7 are called alternate exterior angles. Are called alternate exterior angles. Now, we are having some theorems related to corresponding angles, alternate interior angles. When a parallel line is intersected by a transversal, what is the peculiarities of angles? That is corresponding angles, alternate interior angles, or angles at the same side. Some importance for their value that we are going to express using theorems. That we are going to express using theorem. We are already stated theorem number 1 in this chapter. This is theorem number 2. This is second theorem. Note it down in your notebook. This is second theorem. Second theorem states that if a transversal intersects a parallel line, then the corresponding angles are equal. If a transversal intersects a parallel line, then the corresponding angles formed are equal. Corresponding angles are equal. When a transversal intersects a parallel line, here AB and XY are parallel lines and MN is the transversal. If this happens, then the corresponding angles formed are equal. That is, angle 1 equal to angle 5. We can say that angle 1 equal to angle 5. Angle 1 equal to angle 5. Then angle 2 is equal to angle 6. Then angle 4 is equal to angle 8. And angle 3 is equal to angle 7. These are the corresponding angles and these corresponding angles are equal. These are corresponding angles and these corresponding angles are equal. This is by theorem 2. That is, theorem 2 states that if a transversal intersects two parallel lines, then the corresponding angles formed are equal. Clear? Moving to the next theorem. If a transversal intersects two parallel lines, then alternate interior angles formed are also equal. Alternate interior angles are equal. If a transversal intersects two parallel lines, then alternate interior angles formed are equal. Here we can say that angle 3 is equal to angle 5 and angle 2 is equal to angle 8. These are alternate interior angles and in this case by theorem 2 alternate interior angles are equal. In this case by theorem 2 alternate interior angles are equal. That is, angle 3 is equal to angle 5 and angle 2 is equal to angle 8. Clear? Then next theorem states that if a transversal intersects two parallel lines, then interior angles on the same side of the transversal are supplementary. Interior angles on the same side of the transversal are supplementary. Interior angles on the same side of the transversal are supplementary. Here interior angles on the same side are 2 and 5. Therefore, angle 2 plus angle 5 is equal to 180 degree. Supplementary means sum is 180 degree. And angle 3 and angle 8 are on the same side of the transversal. Therefore, angle 3 plus angle 8 is equal to 180 degree. This is another theorem. So these are the three theorems related to a transversal intersecting two parallel lines. When a parallel line is intersected by a transversal, then first theorem is corresponding angles are equal. Second one is alternate interior angles are equal. Third is interior angles on the same side of the transversal are supplementary. Interior angles on the same side of the transversal are supplementary. These are the theorems related to transversal intersecting a parallel line. Clear? Now we have one more case. I'm going to explain that. The next case is that consider a line XY, another line segment AB, another one is CD. These three are the line segments under our consideration. So related to that line segment, one more theorem is there, and we need to explain that theorem. The theorem is that suppose AB and XY are parallel. If AB parallel to XY, on the same way CD is also parallel to XY. That means AB and CD are parallel to a common line XY. AB and CD are parallel to a common line XY. Okay, AB parallel to XY and CD parallel to XY. If two lines are parallel to a common line, then these two lines are parallel also. That means if AB parallel to XY and CD is parallel to same XY, then we can say that AB parallel to CD. Then we can say that AB parallel to CD. Clear? If two lines are parallel to a common line, then these two lines are also parallel. If two lines are parallel to a common line, then these two lines are also parallel. If AB and CD are parallel to the common line XY, then AB and CD are also parallel. AB parallel to CD. This is another theorem. So now I explained four more theorems. Already explained one theorem in the previous section and we solved two questions related to that theorem. Now I discussed four more theorems. Among these, three of them are related to transversal intersecting parallel lines. And fourth one is two lines parallel to a common line. Relating to this, we can say that if two lines are parallel to a common line, then these two lines are parallel to each other. So we have to solve some problems related to this theorem. Based on the theorems we have explained, we are going through some problems related to the theorem explained right now. That means parallel lines and transversal. The problem is, first one is find the values of x and y and then show that AB parallel to CD. Find the values of x and y. Here is the figure. This is the figure relating to the question. Find the values of x and y. This is x and this is y. We have to find the values of x and y and then show that AB parallel to CD. Then show that AB parallel to CD. Okay. Then look at the figure. We just study right now that if two parallel lines is intersected by a transversal, then alternate interior angles are equal. But here we have to show AB parallel to CD. Now we don't know if whether AB parallel to CD or not. So before that, Before studying parallels and transversal, we studied a theorem that when two lines intersect each other, vertically opposite angles are equal. Here, y is vertically opposite to the angle 130 degree. Here, y is vertically opposite to the angle 130 degree. Therefore, we can say that y is equal to 130 degree. Now look at angle 50 degree and this x is a linear pair. Angle 50 degree and x togetherly formed a linear pair. Thus we can say that 50 plus x is equal to 180 degree. That means for a linear pair sum of the angles is 180 degree. Then we can find x as x is equal to 180 minus 50 is equal to 130 degree. That is 130. Now we got x as 130 degree and y also as 130 degree. We find the value of x and y as 130 degree. Look, x and y are in the positions of alternate interior angles. X and y are in the positions of alternate interior angles. And we got x equal to y and we got the condition x equal to y. That means alternate interior angles are equal here. That means alternate interior angles are equal here. If alternate interior angles are equal, then AB and CD are parallel. If alternate interior angles are equal, then AB and CD are parallel. Clear? First we find x and y. Here y is vertically opposite to 130 degree. Therefore y is 130. Then angle 50 and x forms a linear pair. The sum of the angles in a linear pair is 180 degree. Therefore this 50 plus x is equal to 180 degree. Therefore x is 180 minus 50, that is 130 degree. So x and y both are same 130 degree each. Both are same 130 degree each. They both lies in the position of alternate interior angles. So alternate interior angles are equal here. If alternate interior angles are equal, then the lines should be parallel to each other. That is AB parallel to CD. Hence proved AB parallel to CD. That's our first question. The next question is, if AB parallel to CD, then CD parallel to EF and Y is to Z is equal to 3 is to 7, find X. Here AB parallel to CD. This is the given condition. AB parallel to CD and CD parallel to EF. CD parallel to EF. This is also a given condition. By our last theorem, that means by our fifth theorem, we studied that two line segments parallel to a common line segment are parallel to each other. Here AB and EF are parallel to CD. AB and EF are parallel to CD. Therefore, we can say that AB is also parallel to EF. AB is also parallel to EF. AB and EF are also parallel to each other. Clear? Then, if AB and EF are parallel, then X and Z are alternate interior angles. If AB and EF are parallel, then X and Z are alternate interior angles. X and Z are alternate interior angles. Then we can say that X equal to Z. Then we can say that X equal to Z. AB and EF are parallel. So X and Z are alternate interior angles. Thus we can say that X equal to Z. Now a condition is given that Y is to Z is equal to 3 is to 7. Here look, we already stated that X equal to Z. Therefore in place of Z we can write X. Therefore Y is to X is 3 is to 7. Look at the positions of Y and X. X and Y are on the same side of the transversal. X and Y are on the same side of the transversal. Therefore, Y plus X is equal to 180. Therefore, y plus x is equal to 180. Also, we have a condition y is to x is equal to 3 is to 7. Then to find y is equal to 3 by total of the ratio, that is 10 into total angle 180 degree. 10 and 180 cancels, it becomes 18. 18 into 3, 54 degree. That is, we got y as 54 degree. We got y as 54 degree. Clear? Y as 54 degree. Y is 54 degree. Then what is x? Then what is x? Here we can say that the angles on the same side of the transversal are supplementary. Then to find x, just subtract 154 from 180 degree. 180 minus 54 gives 126 degree. 180 minus 54 gives 126 degree. That is 120 plus 50, 170, 6 plus 4, 10. That is 180 degree. Therefore, x is equal to 126 degree. X is equal to 126 degree. That's what in the question find x. Now we find x as 126 degree. I think it's clear to you. Moving to the next question. The next question is that if AB parallel to CD, if AB parallel to CD, look at the figure. This is AB and this is CD. Already given that AB is parallel to CD. Already given that. These are the given condition. Given that AB parallel to CD. Given that AB parallel to CD. And EF perpendicular to CD. EF is perpendicular to CD. EF perpendicular to CD. And angle GED is equal to 126 degree. Which is angle GED? GED, total angle. Angle GED is equal to 126 degree. This is angle GED. Total angle GED is 126 degree. We have to find angle AGE. We have to find angle AGE. Then angle GEF. Then angle FGE. Okay, look at the figure. AB and CD are parallel. That's given in the question. AB and CD are parallel. Then angle AGE and angle GED are alternate interior angles. Angle AGE and angle GED are alternate interior angles. So AGE is also 126 degree. So we got the first answer as angle AGE is equal to 126 degree. Angle AGE is equal to 126 degree. Next is angle GEF. Also in the question it is stated that EF is EF is perpendicular to CD. EF is perpendicular to CD. Therefore, this angle is 90 degree and total angle is 126 degree. Therefore, remaining is 36 degree. Therefore, remaining is 36. Total GED is given in the question as 126 degree. Angle FED is 90 degree. Therefore, remaining is 36. That means angle GEF is equal to 36 degree. Now, third one is FGE. We have to find FGE. This angle AGE and FGE together forms a linear pair. Therefore, angle FGE is equal to 180 minus 126. That is 54 degree. Now we got all the answers in this question. That is angle AGE is equal to 126 degree. Angle GEF is equal to 36 degree. Angle FGE is equal to 54 degree. Clear? Check if for checking if it is right or not, then we can check like this. FGE is a triangle. It's a right angled triangle. Here it is 90 degree. Sum of these two is 54 plus 36 is 90. 90 plus this right angle 90 is 180. Sum of the angles in a triangle is, you know that it is 180 degree. Okay, clear? All these three problems are solved. It's simple problems. I think it's clear to you. Now moving to the last two problems of this chapter related to the angle sum property of triangle, which we studied right now. In figure, sides QP and RQ of triangle PQR are produced to points S and T respectively. Sides QP, this is the side QP, is produced to S, and RQ is produced to T. Then if angle SPR is equal to 135 degree and angle PQT is equal to 110 degree, find angle PRQ. We have to find this angle PRQ. How to find this? It's simple, we can find. Look, this is angle PQT is 110 degree. Angle PQT is 110 degree. We know that an exterior angle is the sum of remote interior angles. That means this PRQ plus QPR gives 110 degree. And this is also an exterior angle. Then the sum of remote to interior angles gives 135 degree. We can otherwise easily solve this as this 110 degree plus the interior angle is a linear pair. This exterior angle 110 degree plus this interior angle is a linear pair. We know that sum of the angles in a linear pair is 180 degree. Therefore, if this is 110 degree, then the interior angle should be 70 degree. Then it is 70 degree. 110 plus 70, 180. Like the same way, here the exterior angle is 135 degree. Therefore, the interior angle should be 180 minus 135 degree. That means these two are linear pair. Therefore, 180 minus 135 gives 45 degree. Clear? 130 plus 40, 170, 5 plus 5, 10. That is 180. Now, the third angle of the triangle PRQ can easily be found that the sum of the angles in a triangle is 180 degree. That is 70 degree plus 45 degree plus angle PRQ is equal to 180 degree. This is our condition. This is 70 degree, this is 45 degree, and we have to find the third angle. The sum of the three angles is 180 degree. That is 70 degree plus 45 degree plus angle PRQ is equal to 180 degree. 70 plus 45 is 5, 10 plus 4, 11. That is 115 degree plus angle PRQ is equal to 180 degree. 115 degree plus angle PRQ is equal to 180 degree. 115 degree plus angle PRQ is equal to 180 degree. So, angle PRQ is equal to 180 degree minus 115 degree. 180 degree minus 115 degree gives angle PRQ as angle PRQ is equal to 10 minus 5, 5, 10 minus 1, 6, 10 and minus 1, 0. That is 65 degree. It is 65 degree. Now we can check if this is right or not. Here the exterior angle is 110 degree. Therefore, these two angles should add up to 110 degree. 65 plus 45, 60 plus 40, 100, 5 plus 5, 10. It's right. This angle is 135 degree. So, the sum of these two should be 130. Sum of these two should be 135. That is 70 plus 60, 130 plus 5, 135. That is, the answer is right. So, angle PRQ is equal to 65 degree. The next question is, in figure, if AB parallel to DE, the given condition is that, this is our given condition, given AB parallel to DE. Angle BAC is equal to 35 degree. Angle BAC is equal to 35 degree. and angle CDE is equal to 53 degree. Angle CDE is equal to 53 degree. We have to find angle DCE. We have to find this angle. Already we know that AB and DE are parallel. AB and DE are parallel. For parallel lines, if a transversal intersect it, then alternate interior angles are equal. Then this angle 35 degree and this angle are alternate interior angles. Therefore, angle CED is equal to 35 degree, which is same as angle BAC. Angle BAC is equal to 35 degree and CED is also 35 degree. This is because alternate interior angles are equal. Now, this can be marked as 35 degree. Clear? Then in this triangle CDE, in triangle CDE, sum of the angles is 180 degree. That is, one angle is 53 degree plus second one is 35 degree plus third one is angle DCE is equal to 180 degree. Then 53 plus 35 is 50 plus 30, 80, 5 plus 3, 8. That is 88 degree plus angle DCE is equal to 180 degree. Therefore, angle DCE is equal to 180 minus 88, which is equal to 10 minus 8 to 7 minus 8 was not possible. 11 minus 8, that is 10 minus 8 and 7 minus 8 not possible. 17 minus 8 is 90. It is 92 degree. It is 92 degree. Clear? Now we found angle DCE as 92 degree. These three angles add up to 180. That is 92 plus 8, 100, 130, 130 plus 50, 180. That is sum of the angles remains as 180. Clear? Thus, when a triangle is given and to find the angles from the given triangle, we have to use the theorem angle sum property of the triangle. So, that's the last problem in this chapter, lines and angles. What all we have studied in this chapter? First, we studied some basic terms related to lines and angles, such that line segment, ray, then types of angles, acute angles, obtuse angle, right angle, straight angle, reflex angle, then complementary and supplementary angles. These are the basic terms. Then we go through some theorems, and related to the theorem, we have solved some problems. That's all about this chapter. Study the theorem very well, and based on the theorem, other than this, some of the problems are solved here. The problems which are unsolved in your textbook, you have to try to solve this using the theorem we have studied right now. Okay? And best of luck for your studies. I am Nidishas. Thank you for joining me in this section. We will meet in the next section with another chapter in another day.